resultant of parallel forces, including a uniformly distributed load. So in this scenario, this motorcycle, we're trying to find out the total weight, including the passenger weight, the rider weight, the engine weight, and the chassis weight. Everything else other than the engine is distributed 4.5 pound per inches. So you can visualize something like this. So the distribution of the chassis weight in the previous video use a 450 total chassis weight acting and somewhere in the middle. In this video we're explaining that if it's an uniformly distributed load for 100 inches total long motorcycle, what would be the total weight and the location or line of action of that force. Now total weight is easy to calculate. So for the uniformly distributed load, you have 4.5 pounds per inch, and the total motorcycle is 100 pounds total. So 100 inches, so you multiply by the 100 inch, so it becomes 450 pounds total chassis weight, and that will act in the middle. So it will act exactly 50 inches from the left or from the right, so whatever way you measure it. So that's now the total load, so you can simply do that summation of y. Simply everything is acting in one direction, y direction, so that 450 plus that 250 plus 350 plus 400, so the total would be, including the chassis weight, as going to be 1450 total weight. Now that's not a difficult thing to calculate. However, the location of this force, you have to apply the thing called the moment principle or Varignon theorem, which is simply the moment produced by this 450 pound resultant force with respect to any point will be the exact same as the moment produced by their individual components of the forces. So in this case, so that 1450 pounds total resulted, we calculated that moment. Let's say we don't know the distance or location of that force, so we're going to assume that's direction from the front of the motorcycle, so the distance from the front. And now we are taking moment with respect to the front end of the motorcycle, so let's say it's d away. That's what you're trying to calculate, the location of this resultant force. Now for each of these components, for the uniformly distributed load, that is 450 pounds times is going to be in the middle 100 inches from there, plus that 400 pound engine weight will act, that would be 18 plus 25, so that is, I calculated 50. That doesn't look accurate. That's 43. So that's going to be 43 inches from the front wheel plus the rider weight 350. That will be, you have to add that 18, 25, and 17. I found that 60 inches from the front wheel, and then we have the this passenger weight, and you have to add another 15 inches with that, so the passenger weight is 250 times the 75 inches from the front of the motorcycle. So if you solve for D, I found it 54.8 inches from the front of the motorcycle, almost 50-50 balance that we need for a touring motorcycle is, and that's between the two wheels. So but this is from the front, close to what we want. However, the goal of this video is to find out the location of this resultant force, which you apply the Varignon principles. The moment produced by the resultant force will be the exact same as the moment produced by the individual components. If you sum all of these moments, will produce the exact same as the resultant.